This is a Yaesu FT-207R, another Hamfest find recently. This handheld came out back in 1979, and I remember these. This was one of the first synthesized radios handhelds that Yaesu had, and I remember wishing I had one of these at the time. Of course, it was pretty expensive back then in the late 70s. This one was fairly cheap. I think it was $5, believe it or not. Came with the NC1A base charger unit, and here's the unit itself. I didn't get a battery with it, so what I had to do, I just tacked a couple leads on the terminals here. Don't know how it works or anything about it, so we'll go through that and figure it out. Here, I'll turn it on. Squelch seems to work. I've got a HT in the back here, tuned to 147, and I've got this one on 147. Test, 1, 2, test, 1, 2, test. Now it seems to transmit. Let's see if it receives. Nothing. At least on 147. Hook it up to a watt meter. See what kind of power output we're getting here. I've got a watt meter and a dummy load here. Okay, we've got some output. Put it on high power. Yeah, we've got transmitter seems to be working. So I don't know how well it's working, but it's working. I'm going to take the unit apart, try to figure out why the receive isn't working, and then we'll if we get the receiver working, I will do an alignment and we'll put it on the air and see how it sounds. So anyway, knowing the symptoms here of transmit with no receive, I think I'll go through the schematic real quick. Based on that, we'll figure out how we're going to troubleshoot this thing. Stand by for a brief review of the schematic, and then we'll get into the troubleshooting phase. This is a schematic of the FT-207R. Since the transmitter is working and there's some common circuitry that's used between the transmitter and receiver, I can rule out a few of these stages here. So anyway, the problem is somewhere in the receive section here. So I'm going to go through the receive section, and then that'll help us in our troubleshooting. So anyway, here's the antenna input here. Comes in through the antenna connector. And here's a low pass filter here. This is the output, the transmitter output here, but anyway, it's tapped off. The receiver's tapped off here, and I colored in blue the receive path. Comes up through this blue line, up through here, and moving the schematic here. Follow the blue line up here to the input circuit here. Now there's a diode here that during transmit, this would be forward biased, and that would basically short out the input to the receive here to protect the receiver. So it's coupled through a transformer here, T102, to the base of this transistor here, Q101. This is your RF amplifier here, and that's coupled through transformer here, T103 and T104, and that's coupled into the base of the first mixer here. So the first mixer This receives not only the signal coming in here, but I've colored in green here. This is the VCO here. You see the varactor diode. And this produces the signal for the local oscillator for the first mixer and also for the transmit mixer. It's coupled here through Q302. This is a buffer amplifier. So at this point here you can see where the oscillator signal for the first mixer comes up through this section here. Now it's also coupled down to the transmitter, which we know is working. So I know I've got signal here. This is good. So anyway, at this point here, the incoming signal and the local oscillator signal is mixed to produce the first IF at 10.7 megahertz. So then it goes through two crystal filters here, XF101 and 102, and then it's coupled through a transformer to the next stage here. This is your first IF amplifier, and this will amplify the 10.7 megahertz signal. It's coupled through T107 here into this stage here, Q104. Now this stage is pretty interesting. Q104 has quite a few different functions. It's not only the second mixer, but it's the second local oscillator. If you look here between pin 1 and 2, there's a crystal that produces your the oscillator frequency for your second mixer, which is internal here. There's also a limiter. There's a squelch amplifier, a noise amplifier, and a discriminator here that produces your audio output. And here's that chip, Q104. This is a Motorola MC3357. Pretty interesting chip. As it says here, you can read, includes everything. Your oscillator, mixer, limiting amplifier, discriminator, filter, squelch, scan control, everything is all on that chip. And here's the pinout of that chip. So you can take a look here. So you can see on the schematic diagram between 1 and 2 you've got your oscillator crystal here, 10.245, it shows that. And then internally here, it's got a mixer here, and it mixes the 10.7 IF with this signal here to produce the second IF of 455 kilohertz. And then that's output on pin 3 through a filter. Now if you look on here, pin 3, the output goes down through another filter and then an amplifier, and then it's fed back into Q104. The output of Q105, which is it just amplifies that signal, is applied to pin 5, which is a limiter amplifier here. And that outputs on pin 7 here. So the signal's limited through a demodulator, produces an audio output signal on pin 9, which would be up here, pin 9, and that's fed to the audio amplifier. So internally here you've got your noise amp and your squelch amp, and there's a squelch control and a volume control here that are tied back into this chip. They feed an audio preamp here, Q106, and then that drives Q107, and then there's a complementary output audio amp here of Q108 and 109, and NPN and PNP here, and then that drives the speaker. So since I know that my transmitter's working, I know the VCO is operating because I'm getting that signal down here to the transmit mixer. So the problem appears to be up here in the receiver someplace, and I'm not sure. I hope it's not this chip, because trying to find one of those might be kind of tough. Any of these other parts, these transistors, they're easily replaceable. So what I need to do in the troubleshooting procedure, I need to trace the signal coming in and find out where I'm losing signal. So what I think I'll do, I'll try by signal injection, I'll see where I'm losing the signal in here, and then possibly we can find out where the problem is. Anyway, that's the basic operation of the receiver here. The unit comes apart fairly easily. I noticed on this one, see the dip switches here? We might be in for a surprise under here. And it looks like we are. Yeah, it looks like there's a tone board under here hiding. And it has selectable dip switches. This might have been an aftermarket. I'm not sure. I don't remember seeing this on the factory units. Interesting. Anyway, here's the bottom side here of this board. I'll put this section back on. Here's the receiver. This is where we'll be focusing here. So what I'm going to do, I'm going to try injecting signals in here and try to trace out and find out where we're losing the receive input on here. So that will be the next step here. I'm running 147.0 megahertz into the input of the HT here. And if I run the amplitude up here, I'm going to see if I can open the squelch here. But I'm running in 29 millivolts. I'm going to back it off. I'm going to back up. So a real high level of RF in, but I'm not getting any demodulation. I've got a 1 kilohertz tone. I can pick it up with this amount of level. I can pick it up on this one here. So the realistic's picking it up. So it's getting the signal and it's modulated at 1 kilohertz, but nothing. So I'm going to go in, and that's at the input here, at the antenna input. I'm injecting 455 kilohertz into pin 5 of Q104, and that is the 455 kc or kilohertz input here. And here you can hear there's 400 cycles and there's 1,000 cycles. So it's working from 455 on. So the next step, I'm going to inject 10.7 into pin 16 and see if I get any output. So that'll be next. I'm injecting 10.7 megahertz, frequency modulated 1 kilohertz, directly into pin 16, which is here. That's the input. The first IF, which is 10.7 megahertz, input to 16. A little easier to see in this exploded view here. Pin 16. And I'm getting nothing. So what I want to do now, make sure that this oscillator is working here, because if it isn't, it will not mix the 10.7 down to 455. So we've got the 455 injected in pin 5 and we get output. We're injecting 10.7 megs into 16 and we're getting nothing. So that's where the problem is. I have a feeling this oscillator's not working. I'll have to check that next. I'm measuring between pin 1 and 2. And I'm not getting any signal. It doesn't appear it appears that we don't have any oscillation here, so we're not getting the second IF. We're not getting the first IF converted down to 455 kilohertz here. So I have to figure out why. Here's the crystal here, right here. .245 megahertz, that crystal. So either that crystal is dead or we've got another problem. Measured voltage, we've got voltage on the chip. So I already checked that. So I guess we'll have to try something else. To prove that the input is okay up until Q104, I'm running 10.7 megahertz, which is the first IF, into channel 2. And here it is right here. Channel 1 here is pin 16 of Q104. And that's where our IF comes in, our first IF at 10.7 megahertz. So here's 10.7 coming out of the generator here. And now I'm going to trigger on channel 1. And there is the signal coming in from the service monitor. And I'm going to run the level down here so you can see. This is the level coming in at 147.0. And I'm varying the amplitude. So you can see that Q104 is getting its signal. So we're okay up until that point. So that is one more verification that we're getting signal through the input. And I'm running in, see right now there's 8 microvolts, and then it's running down lower. There's 5 microvolts, there's 11 microvolts. So we still have a problem somewhere in Q104. So time to move on, I guess. And I have the signal generator on 10.245 and feeding that into pin 1, substituting for the oscillator. And now I'm going to turn on 147.0, and there I've got output. So we're still having a problem with that oscillator. Let me turn this off. 1, 2, test, 1, 2, test, 1, 2, 3, test, 1, 2, 3, test. Hello, hello. With a handy talkie. So we still got a problem with that 10.245 oscillator on that chip. Ah, boy, I gotta find another crystal and try that. Here's a 10.245 crystal, but I don't know if it'll fit. It might. I'm gonna replace that crystal and see if that works, so I'll do that next. I replaced the crystal here, the 10.245, and it still doesn't work. And on further tests, it's pretty apparent that Q104 is bad. So that would be this chip right here, Q104. So I'm gonna have to find, here's the data sheet again, it's a Motorola part. I'm gonna have to either find a donor or find one of these chips. And the problem appears to be the onboard oscillator in here that the problem is. So until I can find another chip or a donor, I guess this one is going to be set aside for now. Anyway, it's a nice little radio. Like I say, the transmitter works good, but the problem with these old radios is some of the parts that are not obtainable anymore, if they go bad, you're kind of stuck. So I'll have to wrap this one up. So anyway, we didn't get the receiver fixed, but maybe we'll get it fixed in the future. So thanks for watching, and we'll see you in the next one. Bye for now.